Hello, good evening. So, good evening to the participants.
Good evening, sir.
Yes, so it seems like presently there are only three participants. So we will wait for some time so that others can join. participants. We are waiting for some more participants to join with time, so we will commence the session at around 7:10. And
Sir, your audio is not audio.
is it not audible? Is it not audible? Okay, I'll just. Hello. I hope that my audio is the audio quality is better now. Mr. Subhash, can you please confirm? Okay, so I think we'll wait for another 2 minutes. What about the other participants? Is my voice audible? No, I have unmuted it. Hello, is my voice audible? Can anybody confirm? Yeah. So now is my voice audible?
Yes, sir, it's
Oh,
audible.
okay, nice. Thank you for confirming. So it is 7:10. So we will start the session, and I would like to mention that Professor Surya Prakash is going to be joining us. Yesterday he told me that he would be joining us for the session. So if there is any doubts, questions that you have, I request you to prepare them, or even if you have any questions from the week 1, week 2 and week 3 of the lecture, kindly feel free to ask me so that we can have a discussion. And so if there is any questions from the weeks 1 to 3 of the lecture, kindly feel free to discuss. So I will start with the session. Yes, I hope that my screen is visible to all of you.
Yes, sir.
Yes. Good evening, everyone. Welcome to the live interaction session of the NPTEL course, Advanced Reinforced Concrete Design. And this course is brought to you by NPTEL, and the course is being instructed by Professor Surya Prakash of IIT Hyderabad. And presently we are having the live interaction session 3. So in the first session we had introduction to reinforced concrete systems, and in the second session we had the interaction session on the material properties of concrete reinforcing steel. And presently in the third session we are going to be dealing with the topic of durability of reinforced concrete structures. And I am S. Lalit Sagar. I am a doctoral candidate and PMRA fellow in the Department of Civil Engineering at IIT Delhi. And as we have done in the previous classes, I would be the protocol would be such that firstly I'm going to provide a brief introduction on the lecture slides that has been covered so far, and then after spending about 15-20 minutes on the lectures, then we are going to start with the question and answer session. And similar to the last week session, I have prepared around 18 questions for this session, and I hope that we will have a useful and productive evening. First we are going to look at the summary, and then we are going to start with the question and answer after some time. Okay, so this module has been divided into 4 parts. So the first part consisted of the introduction to the durability aspects in the reinforced concrete design. So this would be the overview of the entire module. First we saw the introduction to durability in the first part, and the second part we looked into the different deterioration mechanisms, that is chemical, physical, mechanical, and the corrosion related deterioration aspects. Then we looked into the design approaches, how we design the structures in order to reduce and control the process of deterioration. Then we also discussed about the code provisions which are associated with the durability design. So for this part, the learning outcomes are that we understand the significance of the durability issues of concrete. Then we try to understand the different transportation mechanisms within concrete, and then we look into the different methods of improving the durability of reinforced concrete. So when we are designing a structure, essentially we look into the strength aspects, the strength and serviceability aspect, but durability aspect is equally important, because if a structure is not durable, as you can see, it cannot meet its desired service life. It tends to deteriorate well before the service life, which requires us to perform the repairing functions and restore the structure so that it can achieve the functioning of the regular functioning in terms of the strength and serviceability. So it is important to address the issues of durability during the construction process. So this is what happens to structures if the durability aspect is not taken into consideration. So here we can see that there is spoiling of the concrete cover, and there is spoiling of concrete cover, and there is exposure of the steel reinforcement within the RC structures. So when we try to look into the definition, the durability of structure can be defined as its ability to withstand its design service condition for its design life without significant deterioration or with minimum maintenance. So in order to ensure that a structure is durable, we need to look into the two important aspects predominantly. Firstly is the reinforced concrete system and the environmental conditions. So when we talk about the concrete system, there are certain intrinsic factors such as the cement type, cement content, and the properties that are associated with the concrete. And then we have the certain eccentric factors, that is how the concrete is being prepared, it is being mixed and placed so as to achieve the functions it was initially designed for. Then we have the external environmental conditions. So we have to design the structures in order to withstand the environmental conditions, be it physical deterioration or chemical deterioration and so on. Then the IS 456 and ACI have different definitions for the concept of durability. Moving forward, when we look into the mechanical properties, we are primarily concerned with the strength and stiffness. And when we look at the durability properties, we need to ensure that it has adequate resistance to the harsh environment and it is able to provide the required resistance to the external deterioration processes. So in order to ensure the successful functioning of reinforced concrete structure, we need to consider the synergic effects of the mechanical properties and the durability properties. Moving forward, we look into the link between the durability of concrete and its performance. So right from the process of structural design, detailing the material properties and how it is cured, that affects the nature of the concrete and the distribution of pore, and that affects the transportation process. So the transportation process, as we'll be seeing later on, it is essentially the transportation of fluids and the ions within the concrete. So as the transportation of chemicals become easier, the concrete becomes more and more vulnerable to the process of deterioration, and therein lies the the durability issues. So if you are able to achieve adequate durability properties, then even the performance of the structures can be safeguarded. So here we look into the different types of pores, and some of the most detrimental aspect of these pores is that when there is an interconnection between them. So this makes the process of transportation of fluids and ions much more easier, leading to an accelerated process of deterioration. So these are the different sizes of the pores within concrete. So usually there will be transportation of aggressive agents, so we need to ensure that we provide adequate concrete cover having suitable adequate thickness, and the structure of pore has to be managed so that there is no transportation of deleterious materials. And then we need to design the concrete for against the environmental conditions such as the availability of water and the temperature and pressure factors. Then we need to design them against the different transportation mechanisms such as the diffusion, capillary absorption, permeation, and the migration. So here we look into the process of the aspect of concrete cover. So whenever there is an attack of deleterious agents, if we are able to provide good quality cover concrete, that will enhance the durability and the quality of concrete subsequently significantly over a period of time. So we have the different transportation mechanisms and their associated definition. For example, we have the absorption related to the capillary action, then the permeation, which refers to the flow under pressure gradient, then we have the diffusion, flow under the concentration gradient, and the migration, which is essentially the movement of these fluids and ions under applied electric field. So some of the ways of improving durability are that we can reduce the water to cement ratio, and then we can use small particle size components such as the supplementary cementitious materials, which can fill the gaps within the concrete and improve its durability. Then we have certain mineral and chemical admixtures. So we'll be looking into certain problems and multiple choice questions in order to understand the role of these admixtures in ensuring good durability properties of reinforced concrete. Then we have the chemical reaction when we have the supplementary cementitious materials. Moving forward, we study the diffusion coefficient and how the diffusion coefficient varies when we use supplementary cementitious materials such as the fly ash and the silica fumes, and we are going to be solving certain numerical problems based on these concepts. Moving forward, we use certain chemical admixtures. So in summary, we looked into the introduction to the durability issues. Okay, so I hope that all of you are with me. We can go ahead with the subsequent slides.
Yes, sir.
Yes. So in the second part of the module, we looked into the process of the chemical deterioration. So there are different types of deterioration such as the chemical, physical, mechanical and the corrosion aspects. So these are the when it comes to the mechanical aspects, we have the abrasion and erosion. Then we have, when it comes to the physical, we have the freeze and thaw effects. When it comes to the chemical, we have the alkali aggregate reaction or the alkali silica reaction and the sulfate attack. Then we have the process of corrosion within the reinforced concrete. So coming to the chemical mechanisms of deterioration, we have the alkali silica reaction. So essentially, alkali silica reaction refers to the chemical reaction between the reactive silica that is contained in the aggregates and the alkalis which are present in the cement paste. So this leads to the formation of a gel around the particle of the aggregate particle. So whenever there is availability of moisture, it tends to absorb the moisture from the concrete and from the surrounding environment. That leads to the expansion of the gel, which leads to the subsequent cracking within the concrete. So the process of alkali silica reaction needs to be contained in order to ensure durability of concrete. So it is affected by various factors such as the concrete age, moisture content, high alkali cement and so on. So these are some of the patterns, the cracking patterns due to the ASR mechanism. So some of the ways of preventing or mitigating the effect of ASR is by the use of supplementary cementitious materials, low alkali cement, non-reactive aggregates and the lithium impregnation. So these are some of the tests which can help us to assess the process of ASR within the concrete. Then we have the sulfate attack. So when it comes to the sulfate attack, it can be essentially external and internal. So the external attack can be from the soil, which consists of certain compounds of sulfate such as the calcium, magnesium and so on, and similarly water also. So this is the effect of sulfate upon concrete. So it can lead to significant deterioration in terms of the quality. So as we can see, as we already also saw in the alkali silica reaction, by altering the water cement ratio, by reducing the water cement ratio, we can mitigate the influence of sulfate attack to a considerable measure. Okay, so I think we will continue. So when it comes to the internal attack, we will be looking at the delayed ettringite formation, which we also looked into the week 2 of the lecture. So these are some of the sources of external sulfates, such as the soil, groundwater, and agricultural soil, and the effluents from the furnaces, and so on. So as we saw, the reaction between the monosulfate and gypsum, that leads to the formation of ettringite. So whenever there is a presence of high C3A in the cement, that leads to high heat of hydration, and that leads to the formation of monosulfate, and later on, when it is conducive for the monosulfate, it transforms into ettringite, which is a needle-like structure. So because of the structure of the ettringite, it leads to the expansion within concrete, and that leads to the cracking and other durability related issues. So yeah, as I was discussing in the previous slide, this the process of delayed ettringite formation, that leads to various durability related issues, and these are some of the effects due to the delayed ettringite formation. Moving forward, these are some of the effects of the sulfate attack. So here we can see the exposure of concrete to various sulfate compounds, and as and when the concentration of sulfates increase within concrete, there is significant expansion, and this expansion leads to the process of cracking within concrete. Yeah, so because of the sulfate attack, there can be significant reduction of the strength and mass of concrete. So this affects the stiffness and the strength of the reinforced concrete structures. So here there are some research articles, some results from the research, and in order to prevent the phenomenon of sulfate attack, we have certain types of cement that is being prescribed by the American Concrete Institute code, and by using essentially the type 2 and type 5 type of cement, we can significantly mitigate the effect of sulfate attacks. Okay, moving forward, in the third part of the module, we looked into the physical aspects. The physical deterioration mechanisms. So as we were discussing in the previous class, there can be concrete structures exist in extremely cold areas, and India is also, it is exposed to temperatures of less than minus 35 degrees in certain cold climatic regions. So in cold climates, concrete experiences other types of durability issues, and primarily we have the freeze and thaw effect. So as we can see, water exists as a liquid in the room temperature. However, when it is cooled to sub-zero degree temperatures, it leads to the formation of ice, and it takes up more volume when compared to the liquid water, and when the water that is existing between the concrete cracks, when it is subjected to the process of freezing, that leads to the expansion and subsequent cracking within the concrete. So these are some of the effects of water that is present in pores of different sizes. And again, this process of freeze and thaw is a cyclical process, because water enters the cracks within concrete initially. It cools, it leads to the freezing, it leads to expansion, and the process of heating is otherwise called as thawing. So as and when water gets accumulated in the pores of concrete, it leads to the process of freezing, cracking, and other deleterious effects. So here, as we can see, because of the continued process of freeze and thaw, there can be accumulation of water, and subsequently there can be formation of significant cracks within concrete that can cause the progressive failure within the concrete specimens. So this is another phenomena known as the popping out of aggregate particles. When there is porosity within the aggregate particle, the water tends to accumulate within the aggregate particle, and the process of freeze and thaw leads to the process of cracking within aggregate, and the process is defined as the popping out of aggregate. So because of the freeze and thaw effects, there can be different types of cracking. We have the scaling effect, we have the decracking within the concrete pavements. In order to prevent the deleterious effect of freeze and thaw, we use air entraining agents. So air entraining agents, they induce air bubbles within the fresh concrete, so that whenever there is expansion of the hardened concrete, the expansion can be accommodated because of the existence of these air entraining agents. So we can see that because of the infusion of the air entraining chemicals within concrete, we can safeguard the mechanical properties such as the dynamic modulus and the durability aspects of the concrete. Moving forward, we have the process of abrasion. Abrasion is defined as the attrition because of the rolling of two surfaces between each other. So here we can see the damage to concrete pavements because of the process of abrasion. And we have the process of erosion. So the main difference between abrasion and erosion is that in erosions, the particles are suspended within the concrete, and when the particles set to move, it leads to the process of scrubbing the surface of the concrete. That leads to the deterioration of concrete. Then we have the process of cavitation within the spillways of the dams. When there is the formation and breaking of the bubbles, that leads to the formation of small jets of water within concrete, and when the small jets of water impact the concrete at high velocities, that leads to the deterioration, the damage to concrete, as you can see in this particular these particular images. So these are some of the controlling measures. Then we have the process of corrosion. So corrosion primarily affects the reinforcing steel, and it is one of the major issues when it comes to the civil engineering structures. So the corrosion essentially takes place because the steel rebar provides the anode and cathode, the opposite charged ends of the battery, and the concrete acts as a medium in which the fluids can undergo circulation. And whenever there is moisture, whenever there is availability of moisture, it tends to form rust, and rust occupies significantly higher volume compared to steel. It occupies almost 6 times the volume of the corresponding steel, and because of the expansion within reinforcing steel, that leads to the expansion of the steel and cracking within the concrete. So these are the different mechanisms of crack formation within concrete. These are some of the consequences: concrete staining, spalling, delamination, and so on. Then because of the addition of chlorides, there can be acceleration of the process of corrosion. There will be certain multiple choice questions. We are going to discuss about these aspects of effect of chlorides and the carbonation. Carbonation is related to the absorption of carbon dioxide from the moisture that leads to the reduction in the pH of the concrete, and the steel rebar becomes vulnerable to deterioration. So these are some of the measures to prevent corrosion within reinforcement, and these are some of the effects on the serviceability aspects of concrete. So quickly we will look into the fourth part of the module. So these are some of the design approaches, and we will look into the codal aspects as to how the concrete structures are designed against the deleterious effects of durability. So these are some of the outcomes. We will learn what are the different design approaches that are taken for design against durability. Designing for higher durability. Then we will look into the performance based design. Then we will define the durability index, and we will compare the different codal provisions. So essentially we need to ensure that there is adequate resistance within concrete in order to withstand the deleterious effect of certain environmental conditions and the aggressive aspects of the environment. So essentially there are two types of approaches to the durability design. We have the prescriptive approach, which is being provided by the codes, and then we have the performance based, which is an upcoming method of designing structures for durability. So we have a very nice flow chart where we ascertain the location of the structure, then we characterize the aggressiveness of the exposure, then we identify the dominant mode of deterioration, whether it is physical, chemical, corrosion, and so on. Then we select a suitable service model. Then we design the concrete mix, we design the cover depth, the binder type, and then we will obtain the durability index corresponding to the environmental exposure. Then we test before construction, then we move forward to the process of construction. Then we perform tests on the existing structure, and if it is able to meet our requirements, then we accept it. If not, we can take other steps, such as taking up remedial actions, or we can entirely reject. So moving forward, there are certain tests which are present. We have the oxygen permeability, we have water sorptivity, and the RCPT. We will discuss more about them in the multiple choice questions. And then moving forward, we have the codal provisions. So we have looked into the different codal provisions within the IRC 112, which refers to the Indian Road Congress Building Code for the construction of road bridges. Then we have the IRS 1997. This corresponds to the design of railway bridges in India. And then we also looked into the certain provisions of durability related aspects as per IS 456. Okay, so I think we have taken up more than 30 minutes on this discussion. So without any further ado, we will start with the multiple choice questions for today's session. So I'm sorry about that. Okay, so I think we are ready. I hope my screen is visible.
Yes, sir, it's visible.
Yes, so this is the first question. Which of the following mechanisms are not associated with either physical or mechanical deterioration of reinforced concrete? In other words, you need to select the options that are associated with mechanisms other than physical and mechanical deterioration.
Option C, sulfate attack.
Okay. So anybody else would like to contribute to the discussion? So the hint is that there are two correct options for this question.
C and E.
Okay, E for okay, E for England.
Yes.
Okay, thank you for your answer. Anybody else would like to contribute?
C and E.
Okay, so I think all of you pretty much answered it correctly. So the correct answer is C and D. So sulfate attack is a chemical mechanism that leads to the deterioration of concrete. On the other hand, corrosion is an electrochemical reaction that leads to the formation of rust within the steel reinforcement, and as we discussed earlier, it leads to the decrease in the reinforcement area, and because of the expansion of concrete there is formation of cracks. Moving on, this is the second question. It is related to the transportation mechanism within reinforced concrete. So we have to match the different terms along with the corresponding definition. On the left hand we have permeation, diffusion, migration and absorption. Match them with the appropriate definitions on the right hand side.
So the answer is B.
Okay, B for Bangalore.
Yes, sir.
Okay. Thank you for your input. Anybody else would like to try?
C, sir. C for Calcutta.
Okay. Okay.
Answer is C.
Okay. Okay, so as some of you rightly pointed out, so the answer is C, and the explanation is this. It is adopted directly from the lecture slides, which has been taken in turn from the NPTEL lecture of Professor Manu Santanam from IIT Madras. So essentially transportation mechanism, it is the process of transportation of ion and fluids within the concrete structure. So it is this transportation that leads to the accelerated deterioration within concrete. So we need to check the process of transportation mechanism so as to safeguard the durability of concrete. So we have the absorption. Absorption is defined as the capillary action, and the the value of absorption is ascertained by the sorptivity test. Then we have the permeation. Permeation refers to the flow under pressure gradient, and this is ascertained using the oxygen permeability test. And diffusion refers to the flow under concentration gradient, and this can be ascertained using the RCPT test, rapid chloride permeability. And we have the process of migration, which is essentially movement due to applied electric field. And as with the process of diffusion, even this can be ascertained by the RCPT test. Okay, so absorption is capillary action, performance is the pressure gradient, diffusion refers to the flow under concentration gradient, and migration is associated with the applied electric field. Moving on, so we have certain numericals. So we have the diffusion coefficient, the reference diffusion coefficient dref of Portland cement concrete for a reference time of 28 days. The value of dref is 8 into 10 to the power minus 12 meter square per second. Now, what would be the diffusion coefficient of Portland cement that is replaced with 10% fly ash and 10% blast furnace slag for a period of 365 days? So you need to solve this numerical. It has been adopted from the lecture slides, so I request all of you to refer to the lecture slide and try to solve the numerical by yourself. I hope the question in data is clear to all of you. So we have the value of dref, we need to find out the value of dt corresponding to time of 365 days.
So I'm getting 3.17.
I'm sorry, can you repeat?
3.17 into 10 power minus.
3.17 is it? So is it not in the options? The answer that you got?
One second. So it is wrong.
Yeah, yeah.
Calculation is wrong.
Yes.
$3.37.
Okay, option E. Okay, thank you for your answer. I request others also to try. It is a pretty straightforward problem. Okay, I will wait for another 30 seconds, then we can look at the solution and solve the problem. Okay, so I'll go ahead with the answer. So the correct answer is option E, as one of the participants rightly suggested. So this is the equation. So I would like to solve the example for you, solve the problem for you. Yes. Yes, so we have the value of dref. Dref was I'm sorry, can any one of you tell me what is the dref? Okay, let me first calculate the value of m. So m is given by 0.2 plus 0.4. So we have to substitute the value of percentage FA and percentage SG over here. So we have the value of 10 by 50 because of 10% of replacement of fly ash, and we have 10 by 70. Okay, excuse me for my penmanship. So we have the value of m as
0.337.
yes, we have the value of m as 0.337. Then you plug it in this particular equation. You have dt is equal to can you please tell me what was the value of dt?
365.
No, I mean dref. Sorry, what was the dref? 8 is it?
8 into 10 power minus 12.
Okay, thank you. 8 into 10 to the power minus 12. Okay.
DREF it is. DRE.
Yes, that is
Okay.
dref, and we have tref is 28 days. 28 divided
Yeah.
by 365 raised to the power m, that is 0.337. Solving, we obtain the value of
37.
yes, 3.37 into 10 to the power minus 12 meter square per second. So it is quite straightforward. So this is how we calculate whenever there is replacement of Portland cement with fly ash and blast furnace slag. So I would request you to solve the next problem, which is quite similar to what we solved in this question number 3. Okay, so I invite you all to solve the same problem, similar problem, but the difference is that instead of 10% replacement, we have 20% replacement of fly ash, and 20% replacement of blast furnace slag. So I request you to solve the problem. It is quite straightforward, and if you can kindly explain the physical significance of this diffusion coefficient. So what is happening when we replace Portland cement with these supplementary cementitious materials? Okay, kindly solve the problem.
0.37.
Okay, that is option E.
Yes, yes.
Okay, okay, thank you for your answer. Others also, I request you to.
Option E,
Okay,
2.37.
okay, thank you for the answer. So I will give 1 minute to all the participants. After that, I would be glad if any one of you can explain what is the significance of this value. What is happening when we replace Portland cement with the fly ash and blast furnace slag?
So the answer is E.
Okay, thank you. Okay, so the time is up, and as all three participants rightly pointed out, so the correct answer is E. And for some, if anyone wants to solve the problem, I will give a hint so that they can solve the problem. So for this particular problem, the value of M was 0.474, right? And when you plug it in the equation, we have dt will be equal to, yeah, as the participants mentioned, it is 2.37 10 to the power minus 12 meter square per second. Right. So before moving further, can any one of you explain what is the physical meaning of this the answers that we got?
Diffusion effect is reducing, sir. Durability is increasing.
Yes. So yeah, I think that sums up the answer correctly, because the diffusion coefficient, it is inversely proportional to durability. So we want lesser value of diffusion coefficient. So as we are as we are replacing Portland cement with the different other constituents, we are reducing the value of diffusion coefficient. Okay, so thank you for the answer. So moving forward, we have I'm sorry. Okay, so we have another numerical, and this is with respect to the replacement of Portland cement with silica fume. I request all of you to calculate the answer for this particular question. So we need to determine the ratio of the diffusion coefficients of silica fume concrete and Portland cement concrete. So in the first concrete we have 5% silica fume, and in the second concrete we have 10% silica fume. You have 1 minute. Is anybody able to obtain the answer?
The answer is A.
Okay, thank you for your response. So again, one hint to the participants is that, so as we saw in the previous slide, when we were using replacement of fly ash and blast furnace slag, with the increasing percentage of fly ash and other SCM, the diffusion coefficient reduced. So here also, as we are increasing from 5% to 10%, ideally the ratio has to decrease, right? So we can eliminate the options D and D straight away, because as we are using more silica fume, the ratio is increasing, so that cannot happen.
Option A.
Okay. Okay, thank you for your answer. So as as the participants mentioned, the correct answer is option A, and as I was explaining earlier while giving the hint, the ratio of diffusion coefficient decreases as the percentage of silica fume increases within concrete. So I will quickly try to solve this problem, or at least I will explain the So here we have the diffusion coefficient of silica fume concrete. So that is given by dPc, which corresponds to the diffusion coefficient of Portland cement concrete, into e raised to the power minus 0.165 into the percentage of silica fume that is being replaced, that is being added. Okay, so the calculation is pretty straightforward, pretty simple. So we need the value of DSF by DPC, right? So that is simply given by e to the power minus within bracket 0.165 into SF. So here you simply substitute the values of 5 and 10, and subsequently we will get the answers as 0.43 for 5%, and it would be 0.19 for 10%. Okay, so thank you to the participants who provided the right answer. So at this point I would just like to take a pause, and there are certain participants who are joining with us for the first time. So would you like to take 2 minutes and introduce yourself to the group, your background and what you're expecting from this course? Those participants who are joining us for the first time, if you'd like to volunteer.
Sir, good evening.
Yes.
Myself, Kanaharaj.
Yes, good evening and welcome to the live interaction session.
Sir, I am working as an assistant engineer in Tamil Nadu Water Resource Department.
Okay, very nice, very nice. Okay.
So, just to improve my knowledge, I participated in this course.
Yes, welcome to the course. Actually, in the first week we covered, you might be looking at the weekly lectures by Professor Surya Prakash.
Yes, sir.
And
Yes, sir.
we covered the introduction aspect, then we covered the durability, and in the subsequent weeks we are going to be looking at the design aspects starting next week actually. So next week we are going to start with the axial members, then we have the flexural members. So I request you to stay tuned and make the most of this course.
Okay, sir.
Okay, yeah, kindly feel free to interact with us.
Okay.
Yes. Yeah, thank you.
Thank you. Thank you.
Yes. So anybody else would like to introduce? Okay, if not, I think we can go ahead with the with the remainder of the session. Okay. Right, so we have 18 questions overall. So yeah, without any further delay we will go ahead with the next question. Yes, so we have a picture based question here. For the concrete shell structure, which kind of chemical admixture would you use to increase its durability? So we have many practicing engineers in this interaction session. So if you were assigned excuse me for that. So if you were assigned in a project like this, so which of these admixture would you add to the concrete in order to preserve or increase its durability?
Air.
Okay, thank you for the response. Anybody else would like to answer? So one of the participants said that it is air entraining agent. So let us consider that this is situated in a normal normal climatic conditions. It has nothing to do with the extreme climatic conditions. So the hint for this question is that it has very high surface to volume ratio.
D. Answer D.
Okay, thank you for the response. Anybody else? So as I was telling, yes, please go ahead.
So shrinkage reducing agent.
Okay,
D.
right. Okay, so two of the participants mentioned that it is shrinkage reducing agent. So can any one of you volunteer and explain why we need to use shrinkage reducing agent and not the other admixtures? Okay, so yeah, please go ahead. Yes.
Sir, due to the shrinkage, there will be air cracks will be formed on the concrete surfaces.
Yes.
So to avoid that, shrinkage reducing agent can be used. So
Yes, but the answer is partly correct, but I want to know exactly what is unique in this structure. What is unique in this structure that makes us use the shrinkage reducing agent? Okay, so the explanation is that the correct answer is option D, and the correct explanation is that since the surface area to volume ratio, it is very high, so when there is larger surface area that is exposed to the environment, so that is proportional to the water that is being lost from the concrete. Okay, so that leads to a very high shrinkage. So by adding shrinkage reducing agent, we can reduce the abrupt shrinkage within the structure and the subsequent cracks. Okay, so other options are also correct. I request the participants to mute their microphone, please. Yes. So there are other chemical admixtures also. We have the retarders. So the retarders help in achieving the strength at a slower rate, so that the concrete remains workable for a long time. Then we have the accelerators, which are the opposite of retarders, which help us achieve the strength of concrete quickly. So these are useful in certain different conditions. Retarders when we need to work on concrete for some more time, and accelerators when we need to achieve the strength of concrete quite quickly. For example, in water retaining structures, when the acceleration has to be quick. Then the air entraining agents are more useful in climatic conditions where there is the effect of freeze and thaw, and low alkali cement is useful where we are expecting the effect of alkali silica reaction, and that to degrade the concrete. Okay, so the most appropriate option would be option D. So we have a question with respect to the alkali silica reaction. Select the correct statements among the given options. So there are multiple correct options for this particular question.
So the answer is A.
Okay, C for Chennai.
Sorry, A, sir.
Okay.
The first one. Yes, one.
Okay. So the hint to this question is that there are two correct options. So it is a conceptual question. So you have to identify the two correct statements out of 5.
A and C.
Okay. Thank you for the answer. I request all of you to look at the options carefully because I have modified some words.
A and B.
The
Okay.
answer is E.
Sir, A and E.
Okay. Okay, so thank you all for the response. And the correct answer is there are two correct answers, that is options C and option E. Okay, so I have played with the words here, though. So the alkali silica reaction is a chemical reaction between silica within the reactive silica within the aggregate and reactive alkali in the cement paste. So I have just changed the words here. Okay, so I hope you notice that. So here it has to be silica within the aggregate and alkali within the cement paste. And so option A is incorrect. Option B, so I have mentioned that the ASR gel will form only within the aggregate, but this is wrong because ASR gel forms around the aggregate. So allow me to use annotation. So if we have the aggregate particle, so there will be ASR gel outside it. Excuse me. So if we consider this as the aggregate, the red one, so we have the ASR gel. So the ASR gel not only forms within the aggregate, but it also forms outside the aggregate also. Okay, so which expands upon absorbing that part of the statement is correct. Then option C is correct because as the tensile strength within concrete increases due to expansion, it undergoes cracking. Okay. Option D is incorrect because ASR gel forms at the initial stage and also at the later stage, because old concrete is not free from cracking, because we have seen in the lecture slides that there can be formation of cracks with the aging of concrete also. Okay, so option D is incorrect and option E is correct because the use of supplementary cementitious materials and lithium impregnation, that helps in mitigating the effect of ASR, because as we saw in the week 2 and week 3 of the lecture also, so there are aggregate particles, excuse me, so there are aggregate particles are there. So if these are the aggregate particles, then we have the, usually they tend to form there is products of hydration, and the products of hydration, which is the CHS gel, so these CHS gel, this reacts with the supplementary cementitious materials such as fly ash or blast furnace slag. So that helps in reducing the reaction between the cement and aggregate. So the SCMs are effective against the formation of ASR effects and the cracking within concrete. Okay, so the correct option is options are option C and option E. So again, the correct answer is, it is caused due to the chemical reaction between the silica in reactive aggregates and the alkali in the cement paste. Moving on, yeah, so these are some of the ways of mitigating the effect of ASR. So these are some of the tests prescribed by the American Society of Testing and Materials. So these tests help us in evaluating the progression of ASR within concrete, and then we have the lithium impregnation. So that helps in mitigating the effects of ASR within concrete. Moving on to the next question. What are some of the means of controlling sulfate attack within concrete? So there are multiple options. Kindly take 1 or 2 minutes and let me know the answer. So again, the hint for you is there are 2 correct statements within the 6 statements given. Conceptual question.
Option B and F.
Option B, B for Bangalore.
Yes.
Okay, thanks for the answer.
Sir, answer B and F.
Okay. Okay, keep the answers coming.
B and F.
Okay, okay. So all the 3 participants have said the same answer. So among B and F, one of the statements is correct, but one of them is incorrect. So I request all of you to just think once again, reevaluate the options.
Sir, D and F.
Okay, D for Delhi.
Yes, sir.
Okay, okay, thank you for the response. Yes, so as the last participant mentioned, the correct answer is D and F. Would anybody like to volunteer and answer why options D and F are correct? Anybody would like to volunteer?
I think option B was increasing C2S and decreasing C3A.
Yeah, exactly. Yeah, that was the, yeah, right. Yes, as, yeah, so that was a very nice observation actually. And option A is incorrect because increasing the amount of gypsum that leads to the formation of, that can possibly lead to the delayed etringite formation. And option C, as one of the participant very rightly told, mentioned that we have to increase the value of C2S because of the low heat of hydration, and we have to reduce the value of C3A, right, because it has a high heat of hydration. Then, as we mentioned in the previous class, we need to cure the concrete at temperatures below 50 to 65 degrees, because again curing them at high temperatures leads to delayed laterite formation. And use of supplementary cementitious materials, these are not only useful in preventing the in mitigating the effects of alkali silica reaction, but they are also effective in controlling the sulfate attack to some extent. Okay, and the air entraining agents, they are primarily used in regions of cold temperatures to mitigate the effect of freeze and thaw. And option F, as the question itself suggests, we need to use the sulfate resisting cement. So yeah, thank you for participating, and the correct answer is D and F. Yeah, so this is the effect of sulfate on concrete. So I think apart from corrosion, it is one of the main challenges when it comes to the effect of when it comes to the durability aspects within concrete. So it can corrode the structure significantly, leaving just the rebars, and it can even consume rebars after some time. Okay, so whenever there is scope for contamination or high sulfate content, we need to design the structures accordingly. Okay, moving on. Yeah, so this refers to the the options. So when we have gypsum is being formed, we have the products of hydration. So in order to take away the gypsum, we need to use the supplementary cementitious materials such as fly ash, silica fume, blast furnace slags. So this will reduce the effect of sulfate attack on concrete, and we need to maintain low water to cement ratio to mitigate the effect of to reduce the permeability of concrete, and also we need to reduce the effect of the content of C3A within cement, and wherever possible and wherever we are expecting that sulfate attack is going to happen, we need to try and use sulfate resisting cement as much as possible. Moving on, so the popping out of aggregate particles is associated with which kind of degradation mechanism in concrete? We have 5 options.
B.
Okay, B for Bangalore.
Yes, sir. B.
Okay. Okay, thank you. Anybody else would like to try?
Sir, D. Freezing and thawing of concrete.
Okay, thank you for the response. Anybody else? Okay, as one of the participants rightly pointed out, so the correct answer is freezing and thawing. Okay, so when I was discussing the summary earlier in the session today, so I mentioned briefly about the popping out of the popping out of aggregate. So, excuse me. using red for better visibility. So this is the process where there is whenever there are pores, there is accumulation of water, and water tends to fill up in these cracks, and whenever there is freezing, there is expansion of the volume of water when it forms ice, and that expansion leads to the cracking, and because of cracking more water gets accumulated. So it is essentially a cyclical process. So as and when the water accumulation takes place, water accumulation, again freezing and thawing, it leads to the formation of wider cracks. However, if we take this aggregate particle, so this is essentially an aggregate particle. So if aggregate has some pores, as you can see here, whenever there is ingress of water, water tends to accumulate in the pore within the aggregate, and whenever there is freeze and thaw effect, freeze and thaw within the aggregate particle, so the aggregate particle can rupture. So this phenomenon is called as the popping out of aggregate particle. Okay, so thank you for the response, and we'll move ahead to the next question. So when it comes to the different types of cement, what do the type 2 and type 5 cement correspond to as per the American Building Code on requirements for structural concrete, that is ACI 318? So similar to the IS 456, the Americans have the ACI 318 code. So in that code, what do the type 2 and type 5 cement correspond to?
Option A.
Right. Thank you for the response. Anybody else would like to volunteer? Okay, so without any delay, we can go to the answer. So as one of the participants rightly mentioned, the correct answer is option A. So we were looking at the different types of corrosion, right? Excuse me, I will open the PPT to explain this. I think we were in right. So allow me to use the pen for this one. So we were looking at the different types of deterioration mechanisms. We have the physical, we have the mechanical, and we have the chemical, and then we have the corrosion, right? So the first two corresponds to the process of sulfate attack. So in chemical we had the alkali silica reaction, and then we had the sulfate attack, right? So in order to mitigate the sulfate attack, what do we do? So in order to mitigate that, one of the steps is that we limit the amount of C3A. So as I was mentioning, and one of the participants also mentioned, C3A is associated with the high heat of hydration. So whenever there is high heat of hydration, so that leads to a delayed retrograde formation. Okay, so we know that DEF leads to the cracking within concrete and durability related issues. So in order to mitigate the cracking, we need to reduce the amount of C3A that is added within the cement, right? So we have to reduce the amount of C3A. So option A is the correct answer. C3A was given just to confuse you. And again, I repeat that the air entraining agents, it is for freeze and thaw, and type 2 and type 5 are not associated with air entraining agents, and neither are they associated with the sulfate resisting compounds, and it is not also associated with the RCPT value, right? Yeah, so this is taken directly from the code. I'm sorry, taken directly from the lecture slides. Okay, so this is the guidelines, right? So this is the sulfate content. If we are constructing in a soil with different amount of sulfates, less than 150 to 1500, correspondingly we can take up type 2 and type 5 cement, and we can also use the SCM, and we can reduce the water cement ratio. So these are some of the ways of mitigating the effect of sulfate attack. Okay, thank you for the answer, and we'll move on to the next question. So we need to match the different mechanisms with their appropriate definitions. I hope all of you can see my screen. We have cavitation, abrasion, erosion, and corrosion.
Option D.
Okay, D for Delhi.
Yes.
Right. Thank you for the answer. Anybody would like to volunteer, or
So the answer is D.
okay, thank you. Yeah, so as the participants mentioned, so the correct answer is D. It is quite straightforward. Excuse me. So yeah, I need to switch to the Google Slides, so that yes, option D is the correct answer, and it is quite straightforward. Cavitation refers to the rapid development and dissipation of water bubbles, which we see in the spillway of the dams. Then we have the abrasion. Abrasion refers to impact of small particles. Erosion, it is associated with the particles within a moving water, which results in the scrubbing of a surface. Then we have the corrosion, which is an electrochemical process. A lot of research is being undertaken with respect to the corrosion in steel reinforcement. Okay. Moving on, so again a picture based question. So I would request you to match the following mechanisms of deterioration within reinforced concrete with the appropriate pictures. Okay, anybody would like to volunteer? It's a quite straightforward question because we've already seen the definition in one of the previous slides. Anybody?
Option D.
Okay, T for Delhi?
Yes.
Okay, okay, thank you.
So option C.
Okay, thank you for the response. Anybody would like to add?
Option C.
Okay,
Sir, option C.
okay, okay, thank you. Okay, I think all of you, answered correctly. So yeah, it is quite straightforward. Like option, cavitation is depicted in C, figure C, and corrosion depicted it with B. It shows the staining of reinforced concrete, the leaching of the rust to the concrete surface. Then freeze and thaw is represented by this decracking, and ultimately the ASR is shown in figure A. Thank you for the answers. Moving on, which of the following factors are responsible for corrosion in steel reinforcement? Very straightforward conceptual question, and you need to select multiple options. So just to give you a hint, there are three correct options.
Sir, B, C, and D.
Okay, B, C, and D.
Yes, sir.
Right. Okay, thank you for the answer. Okay, just to give the hint to others who are attempting, out of the three options that the participant mentioned, two are correct.
A, B, D.
Okay. Okay, again, there are two options which are correct out of the three.
So B, C, and D.
Okay. Okay, thank you. Okay, so I'll go ahead. So the correct options are B, D, and E. So when we are looking at the properties of reinforcing steel, concrete does not have direct role to play, whereas the chloride ions, they are known to accelerate the process of corrosion. And hot and humid climate, though it is indirectly responsible, it is not directly associated with the corrosion in steel. Again, carbonation, as we saw in the previous week's lecture also, it is an important factor that is responsible for corrosion. And option E also, when we are using dissimilar materials, it can happen when we are providing a lapping between, splicing between two rebars. So we need to be careful, because when we are using dissimilar materials, that can lead to the process of corrosion as well. Okay, so the process of corrosion, again, as I was mentioning, it is a very significant problem in terms of the durability of concrete in the research field. So basically, the rebars, it provides the conducive environment for the process of corrosion. And because steel is an alloy, essentially the iron and the iron oxide, they are the more natural products. So it tends to attain its stable state from steel to the rust. And basically there is transportation of ions within the reinforced concrete, and that leads to the formation of, because of the transportation of the ions, the Fe2 plus and OH ions, there is a chemical reaction. And whenever there is presence of moisture within concrete and oxygen from the environment, that leads to the formation of different hydroxides of iron, which is nothing but rust. So rust is about 6 times greater in volume when compared to steel. So that leads to the expansion of steel rebars and subsequent concrete. Okay, and again, the two primary mechanisms responsible for the corrosion is the ingress of chloride ions and the carbonation of concrete. And as we saw in the previous lecture, because of the absorption of carbon dioxide from the environment, it leads to the formation of carbonic acid, and the pH of concrete reduces. When the pH reduces, then the protective coating around the reinforcing steel is destroyed, and that leads to the process of corrosion. And in the cold countries, usually there are the de-icing salts which are used in order to dissolve the snow or ice that is getting accumulated on concrete. But this salt, because it contains chlorides, it tends to induce the ingress of chlorides within concrete, and that can accelerate the process of corrosion. So whenever we are using these kind of chemical agents, we need to be careful about the issue of chloride attack. So yes, so ultimately the correct option is ingress of chloride ions, carbonation of concrete, and use of dissimilar metals. Moving on, we have the next question. Which of the following options are incorrectly matched regarding the prescriptive and performance based durability design of concrete? So there is one
Option C.
yes
C.
yes thank you. So there is one incorrect option, and it has been taken directly from the lecture slides.
Option C.
Okay, thank you for the response. Right. So further, without any delay, we will look at the answer, and the correct answer is option C, because so those who are working in seismic I mean earthquake resistant design, so I am also working in earthquake resistant design of structures. So the concept of performance based design, that is very very upcoming topic, so we usually design the structures to achieve a certain kind of performance. In earthquakes, it is with respect to a particular drift level, and when we extend that concept to the concept of durability, it leads to a satisfactory design life, satisfactory service life. Okay, so again, the prescriptive design, which is based on the building codes, that it aims to avoid deterioration. Service life is not specified, and durability is being assumed. It is being assumed when you provide a certain concrete cover and when you provide a certain concrete composition. On the other hand, when we are designing based on the performance based design, usually it is designed for durability, and a service life is specified, let's say 50 years or 60 years. And instead of saying that we are going to avoid deterioration completely, we are saying that we are going to provide only resistance, which is more realistic, because obviously durability and deterioration is a part and parcel of any structural building. So it makes more sense that we are using the term resistance than using the term avoidance. Okay, so the correct option is option C, so it is interchanged, right? And this is the flow chart that I also explained, and I think this would explain the crux of the concept of performance based design, right? So moving on. Yes, identify the incorrect statement with respect to the tests on durability of concrete. So out of the 6 statements, there is one incorrect statement. So I request the participants to kindly identify the incorrect option.
Option F.
Okay, thank you for the answer. Anybody else would like to volunteer? Sorry about that. Okay, so the question has been taken directly from the lecture slides, and the correct answer is option B for Bangalore, because oxygen permeability test, it is conducted to evaluate the resistance of concrete to carbonation. However, if it yeah, so if the value of OPI is higher, the susceptibility of concrete to carbonation is lower. Okay, so as we can see, if OPI is very high, for example 10 and so on, it means that it is of very good it is having very good durability properties. Okay. On the other hand, other options are correct. Water sorptivity test is conducted to measure the water penetrable porosity. Higher the sorptivity value, greater is the concrete porosity. Again, higher the value, greater is the porosity. RCPT is conducted to determine the resistance of concrete to chloride penetration. Higher the value of conductivity, greater is the vulnerability of concrete towards penetration of chloride. Again, all the options are correct, so I request you to just go through the tests once again. Moving on, so this is again based on the prescriptive durability design. So 3 questions are interlinked to one another, 16, 17 and 18. So for concrete structures which are constructed in a coastal environment, so which category of environmental exposure conditions they are classified under as per the IS 456? And if you are using M40 concrete, what should be the corresponding nominal cover to the reinforcement?
Sir, option E.
Okay, thank you. So whenever you are a student of student of this course, or whenever you are a design engineer, and whenever you are designing a project for coastal environment, so you need to refer the IS 456 to determine what is the environmental exposure condition and what should be the corresponding concrete cover that needs to be provided. So once you provide the concrete cover, then the effective depth is going to vary accordingly, so it becomes very important. Anybody else would like to volunteer? Anybody here is presently in coastal region? Because you should be knowing, living and practicing over there, you should have an idea. So moving further, the correct answer is option C. So if we look at the table 3 of IS 456 clause 8.2.2.1, so we have the nominal cover to the reinforcement. So that is, the exposure conditions are presented in this table, in table 3, and the nominal cover is presented in table 16. Okay, so based on that, whenever we are designing a structure in coastal environment as per IS 456, we will consider severe environmental exposure and nominal cover of 40 mm. Yeah, so this is the table 3 and table 6. I request all of you to just see the table 3 and just try to identify based on the current location which environmental condition comes for you personally, and what should be the nominal cover. Okay, that should be an interesting and homework. Okay, now for the environmental conditions mentioned in question 16, what should be the minimum cement content, maximum water to cement ratio, and the minimum grade of concrete? Anybody would like to volunteer? we have just one question after this. So again, when we are doing concreting, you should be knowing how to what does the code say regarding the mixed design, right? For severe environmental condition.
So the answer is C.
Okay, thank you for the response. Anybody else would like to volunteer? So you can, the reference is the lecture slide, but I would always recommend you that look at the codal provisions directly, so as to ascertain that the answers is correct, right? So the correct answer is option A. So the properties are given in table 5 of IS 456. So yeah, here we have. So for for severe environmental exposure conditions, the minimum cement content has to be 320 kg per meter cube, and the maximum water to cement ratio is 0.45 and M30. Right, so the option is the correct answer. And we have the last question now for the day. Okay, so this is an application oriented. It is intended to build a road bridge across the backwaters of Kerala exposed to coastal environment. What would be the minimum grade of concrete, minimum cover, minimum cement content, and maximum water to cement ratio? Assume 20 mm size aggregates and factory made precast elements are used for the construction of the bridge. Assume a service life of 100 years. So this is a very hands-on kind of a problem. So in the previous two questions we had looked at the provisions of IS 456, which pertains to the reinforced concrete construction of the structures, and this particular problem corresponds to a road bridge, and we have to refer to IRC 112. So that contains all the necessary guidelines.
So the answer E.
Okay. So may I know if you're actually referring to the codes? Okay, I would recommend that all of you just go back and refer. We will discuss the answer also, but IRC, I think the 2020 version is relevant. I mean, it is available. I think yeah, IRC 112. I think 2020 version is available. So the reason why I am saying is that as we know, IS 456 that came up almost 24 years back. So if there is any updates regarding the RC construction, we are expecting a new building code also for reinforced concrete, but in the meantime we can just get the knowledge of what is the construction practices for the road bridges, right? So the correct answer is option E. Thank you to the participants for providing the right answer. And yeah, as I was mentioning, I have to refer to this code. and these are the values I have taken. So yeah, I think the participants, they made a very nice observation here, because we are referring to the factory made precast elements. So whenever we are assuming 20 mm aggregates, and then when we are using precast elements, we can actually have a relaxation because it is of a higher quality. We can actually reduce this minimum cover by 5 mm. So ultimately the answer is the minimum grade of concrete is yes, minimum grade of concrete is M30, minimum cement content is 360, maximum water to cement ratio is 0.45, and the minimum cover is 0.4, right? M30, 40 mm, 360 kg per meter cube, and 0.45. So I think with this we have come to the conclusion of this live interaction session, and if there is any feedback that you would like to let me know, I welcome you. If not, we can end the session at this point.
So this in this session we have got adequate knowledge, sir.
Right. So
We have got more things such as the IRC 112,
yes,
like that.
yes,
Sir, one more thing, sir. Shall we have this slide, sir?
yes. We will be uploading. There is a Google Drive, where I am uploading all the presentations, and this video recording is also made available to all of you. It is being uploaded in YouTube, and you can watch it as per your convenience. So again, as I was mentioning in the previous lecture interaction session, there are two objectives. Firstly, we are trying to give you a practice on how to solve the assignment questions, and give you a practical feel for all the concepts that are being covered on a weekly basis. So yeah, I hope that I'm able to meet the expectation and do some value addition to the lectures of professor. Okay, so if there are no further comments, we can end the session. I thank you all once again for attending the session with me, and I look forward to meeting you all next week. Next week we will be doing the actual members.
Thank you so much, sir.
Yeah, thank you so
Thank you,
much
sir.
for attending.
Thank you, sir.
Yes, good night to all of you.